Could Proxima B be Earth's cosmic twin? Ever since its discovery, this intriguing exoplanet has sparked curiosity, as scientists suspect it may be hiding something extraordinary. Not only is it similar in size to our planet, but it also orbits within the habitable zone of its star, the sweet spot where conditions could allow for liquid water, and potentially even life. Let's kick things off with a quick quiz. How many planets are there, 8 or 9? Do we still count Pluto? Well, that's not the whole picture. We can't forget the vast number of planets that exist beyond our solar system. These are known as exoplanets, worlds orbiting stars other than the Sun. And get this, we've discovered 6,911 exoplanets spread across 4,941 different star systems. So the big question is, could one of them be an Earth 2.0? On paper, at least, the odds are looking surprisingly promising. The truth is that the almost 7,000 known exoplanets are just the tip of the astronomical iceberg, and experts estimate that there could be up to 50 billion more planets in the Milky Way alone. In view of this, more and more researchers are answering the oldest question of mankind, whether we are really alone in the universe, with a clear no. But is it even possible for us, from our earthly point of view, to catch a glimpse of those extraterrestrial life worlds that are millions of light years away from us? Well, this question is certainly justified. But perhaps, at the end of the day, it is not at all necessary to venture so far into the depths of space to track down the existence of our hidden contemporaries. Because, true to the motto, why look so far afield when the extraterrestrial is so close, it could be that the next alien civilization is slumbering just an astronomical stone's throw away from us. After all, no other exoplanet is quite as close to us as Proxima B, nestled in the constellation Centaurus and discovered back in August 2016. It holds the title of the nearest known exoplanet to Earth, just 4.2 light-years away. But let's be real, how far is that, really? Try a staggering 37.84 trillion kilometers. And with today's propulsion systems, it would take us thousands of years to cover that distance. Luckily, here's the silver lining. We've reached a point where we can explore the universe's secrets without physically traveling to the stars. And thanks to that, we've discovered that Proxima B isn't alone out there. It shares its orbit around the red dwarf star Proxima Centauri with at least 2 other planets. But how do you even detect a celestial body that is trillions of kilometers away from us? Are the James Webb telescopes of our time really so powerful that they can directly detect and capture images of alien worlds? Well, not quite. In reality, indirect detection methods have proven to be the most successful for this. This applies in particular to the so-called transit method, in which a planet reveals its presence was not detected by observing a dip in the brightness of its host star, as is common with the transit method. Instead, in the case of Proxima B, the breakthrough came through the radial velocity method. In simple terms, this technique works like this: a star's gravity holds a planet in orbit, but the planet, in turn, also exerts a slight gravitational pull on the star. This causes the star to wobble ever so slightly. Even if that motion is only a few centimeters, it's enough for astronomers to spot, and enough to signal that our cosmic maps need updating. So, could Proxima B be Earth's twin? Now that its existence has been confirmed, the natural next question is, what exactly is this planet like? And more importantly, could it be habitable? To even be considered potentially life-friendly, one key requirement must be met: the planet must lie within the habitable zone of its star system, the region where conditions might allow liquid water to exist. This means that it orbits its star at a distance that allows the existence of water in a permanently liquid form. And yet, that is not the end of the story by a long shot, because other factors, such as the atmospheric composition of the planet or the radiation of the parent star, can still throw a decisive spanner in the works of the development of life, despite all favorable starting conditions. But what about the case of Proxima B? Well, with an estimated mass of 1.17 Earth masses, it's generally classified as an Earth-like exoplanet. But be careful, the word Earth-like does not make any statement about the potential habitability of a celestial body. It merely describes rocky planets with a solid surface. And while our Earth takes 365 days to orbit the Sun, Proxima B only needs a little over 11 days for one orbit. Consequently, the distance between the exoplanet and its host star is significantly smaller. In detail, the corresponding distance is just 7 million kilometers, and in view of this, one might think that Proxima B is transformed into a scorching hot furnace by the radiation of its host star, but that is not true. While our Sun is classified as a yellow dwarf, Proxima Centauri is a red dwarf with only about 12% of the mass of our life-giving star. However, the distance and nature of the host star are not the only ways in which the Proxima Centauri system stands apart from our own. Another key difference is that, according to our data, Proxima B likely has a tidally locked rotation, meaning one side always faces its star. As a result, the planet experiences a stark contrast between a frigid night side and a scorching day side. But what does this mean for the possibility of life? Does this sharp division rule out habitability? Not necessarily. Between these extreme zones, there could be a narrow region where conditions are more suitable for life. Moreover, the contrasting sides of the planet might even help create favorable conditions in this twilight zone. Interestingly, the scientists' simulations have shown that the habitable area could obtain its liquid water supply from the glaciers on the night side. These would melt near the twilight zone, feeding the lakes and rivers. Has Proxima B already produced life? But what temperatures are actually the norm on Proxima B? Well, the experts have calculated an equilibrium temperature of -39 degrees Celsius. To clarify, the equilibrium temperature is the temperature that a system reaches on its own after a sufficiently long period of time. However, this does not mean that the equilibrium temperature necessarily corresponds to the surface temperature. If Proxima B has an atmosphere, its temperature could be much higher due to the greenhouse effect. Our own Earth offers some insight into this. Without an atmosphere, Earth's equilibrium temperature would be -8 degrees Celsius. Now, let's address the big question. What are the chances that life could exist on Proxima B or that life has already developed there? This ultimately boils down to one key factor, the presence of liquid water, which depends on several parameters that haven't been definitively resolved yet. However, simulations that considered a favorable orbit and atmospheric composition suggest that Proxima B could indeed have liquid water. Still, the question of its habitability remains hotly debated among scientists, mainly due to the intense activity of its host star. A few years ago, experts from the University of Colorado observed something that eclipsed everything previously known. It has long been known that the Sun repeatedly attracts attention with radiation bursts, so-called flares, but the bottom line was that what the researchers saw flickering on Proxima Centauri was, believe it or not, 100 times stronger than any solar flare documented to date. In fact, the star increased its ultraviolet radiation by a factor of 14,000 within a few seconds. And indeed, the eruptions there are not only significantly more intense than on our Sun but also much more numerous. Based on this, one could assume that the extreme radiation would destroy the entire atmosphere of Proxima B over time, thus destroying any chance of life. But it's not quite like that. After all, there is also a scenario in which the planet does not lose its gas envelope to space. To achieve this, the planet would need a liquid core capable of generating a stable magnetic field, which would protect it from the harmful radiation emitted by Proxima Centauri. This magnetic shield would help preserve essential elements like oxygen and water. Alternatively, some scientists propose that Proxima B may have originally formed farther from its star and was only later pulled in by its gravity. Additionally, it's possible that Proxima B once had up to 10 times more water than Earth. Even if intense radiation from the star had already stripped away 90% of that water, there could still be enough remaining to create a vast ocean that spans much of the planet's surface. However, due to the planet's tidal locking, the water would likely remain at moderate temperatures only in the narrow twilight zone.